Hey everybody, this is Dan Petrock. This is the solutions video for chapters 1 through 3 for stats spring 2013. Oh, sorry about that. Okay, this is an observational study for number 1 is the correct answer because we never want to experiment on things that might hurt people. We don't want to harm human subjects. So that was the key here, to realize that we should observe things and shouldn't purposely have treatments that hurt people. So, and I think everybody got that right. Number 2, an alternative thing. I got a lot of interesting answers here. The biggest errors I saw would be things like either agreeing with this, which is not an alternative conclusion. They say, yeah, piano helps you be smart. I'm like, well, that's what that's saying. What's an alternative thing that might be explaining it? Most of you said, oh, it's just correlation. Most of you said, maybe really smart people are just good at instruments, but playing the instrument did not make them smart. Things like that. This is, and you see a lot of this, people trying to jump to causation when it might just be correlation. And number 3, it says, what's the difference between, what is blinding? Single blinding is when only the subjects are blinded. That means the patients or whatever they took it. And a lot of you missed the second part. It says explain why the absence of double blinding could cause a problem. Many of you are saying, oh no, that's horrible if it's double blinded, and the doctors don't know who to treat or what treatment. And the researchers know. The doctors are part of the evaluation tool. They're trying to figure out if it's working or not working. It's good to keep them blinded so they're not biased when they're measuring results, or might accidentally say something to tip off the patient that they're really not taking the drug or whatever it is. So we don't want the doctor to have any bias. That's why we should blind them as well. I actually had one of my kids go through some kind of study and they gave him a shot. Well, we found out like 2 years later there was nothing in those shots, but the doctor didn't know that either. So they're blinded as well. So so they weren't biased to either not give it or say something. So it's important to do that if you can. Number 4, which one are affected by adding a constant? That just raises the average and the median, but it does not change the spread. So the last 3 are all measures of spread. It doesn't really change those, but it does change the measure of center. So it's mean and median. Number 5, is it random? Yep. They all had an equal chance to be picked. What's the sample? It's the 50 college students, and the population would be everybody at this school, or the 2,560 students at this school would be the population they're referring to. Number 6, here's kind of my crappy drawing, but here's a histogram. There's no gaps. Got it labeled. The midpoints, I allowed a few different, we have the frequency over here. And it says, does this appear to be normal? The answer would be no. And it's definitely not unimodal, and it's definitely not bell-shaped. We get this big stack here. It looks like it's actually skewed right and things like that. So definitely not normal. Number 7, what's wrong with this? Right here, there's no 0, so they're misleading us. These bars would be much taller, so it makes these differences look much bigger. So it is misleading us. And then how would you describe the shape of the data? And you'd say it's unimodal. It's got one dominant peak here, and it's also skewed right. I think on this one I didn't count them wrong if you had at least one thing, but I was really looking for 2 or more things to describe the data, but that's about it. And number 8 is the find the quartiles, box and whisker. I assumed both methods here. If you used 2 with the top and bottom, or with neither, because there's an odd number of data here. But there's the average and the quartiles. I also assumed you could use 0 as a quartile if you obviously didn't use that one, that moved it over. So the blue are the alternative and the black is like the one way. So there's the different ways, but there were 2 outliers, 13 and 17. And finding the fence, 1.5 IQRs. I did it both ways there. And then there's the box and whisker plot. One There is no whisker because the first quartile and the lower extreme are the same. The other one does have one. Make sure you have a scale here to reference against, or else it's not valid too. So number 7, here's 2 side-by-side box and whisker plots. A lot of you maybe had just a similarity or just a difference. I'm looking for at least one of both. So you could say this looks, this would be pretty symmetric because the top and the bottom are the same. It's probably unimodal. This looks like it's more skewed to the right. They do have a similar width of their interquartile ranges. You could say the second one has a higher, more range. There's lots of different answers I accepted here, but I wanted to at least see at least one similarity, at least one difference. More is even better. On 10, find the z-scores, draw the pictures, nice. There's the average, there's a test score, it's 1.5 standard deviations above average. There's the mean, there's average is 75. The standard deviation is much less, there's much less spread. That's actually 1.75, so that is the better score. It's higher, it's farther away from normal. And number 11, find the z-score here for this basketball, 6.9 compared to 6.1. They're 2.23 standard deviations above the mean, which is, yes, very unusual. Usually we say 2. Anything more than 2 is unusual. And number 12 here, draw your normal distribution. Average is 120. Or, the question is essentially what's 100 or less. So we find the z-score is negative 1.33. If you look that up on your z-table, it's 0.0918. And so that's the probability of getting 100 or less for your blood pressure. What's the probability that's over 150? Same thing. We get a z-score of 2. Look that up in our z-table, 0.0228. Sometimes people forgot to find the area to the right. They're finding area to the left. But what comes in handy is when you're trying to find the area between, essentially to the left of this one and to the right of this one, it's really handy just to use this 0.9772, which is all of the left, minus what's left of here. We'll leave what's in between. So 0.9772 minus 0.0918 gives you about 88% or 88.5% of people are between 100 and 150. 13 is the standard deviation one. The average is 8. For some reason, people had more problems with this than I thought they would. Just find the difference each data point is from the mean, square those differences, divide by n minus 1. Some people forget to take the square root, but so there's the answers. Contact me if you have any questions, and I hope this helps you get ready for the final, or this is a following semester, get ready for the test coming up.